Hi all, this is Mr. Yeager for chemistry. We're looking at balancing chemical reactions today. So we talked about all the different kind of properties and characteristics of chemical reactions, identifying how to recognize a chemical change that occurred, and obviously the setup for a chemical reaction, which again we call it a chemical equation. And we are now getting into, we also talked about types. And then we're getting into balancing actually the chemical reaction now, where we have the same number of atoms of each element on both sides of the equation. And this is due to the law of conservation of mass. We cannot create or destroy mass. It can only be changed into other forms, or in this case, compounds. So we are going to be very interested in basically balancing out these equations as we go through them. And we're also going to identify the type, because again, that's going to be very important as we get to predicting products. And it's very similar to what we do on the test, where it's usually balance this reaction and tell me what type it is. All right, so there's a couple ways to go about this. I'm going to kind of show you my primary method, and then I'll give you a secondary method to kind of play with if you'd like. But I'm primarily going to be using that first method, where you'll see me kind of bounce back and forth. But this right here is a synthesis reaction. I know that because I'm bringing together two lone elements, and they're becoming a compound together, okay, is what we're looking at there. All right, so the way I really would be looking at this more than anything else is I just take my time and go element by element and try to determine how I can have the same number of both elements on either side by adding coefficients. So again, very, very clearly, I want to point out, we are not going to touch these subscripts. Okay, we are not going to add any subscripts, okay, at all. We are only going to be adding numbers in front of the compound, and again, those numbers are called coefficients. Those are going to be multiplied with the subscript to equal the total number of atoms you have of that type on either side. Okay? But again, we're trying to make both sides equal. You can consider this little arrow, this yield arrow, as an equal sign where we want both sides to have equal number of atoms of each type. So here we go. So we said this is a synthesis reaction. Sorry, let me get rid of that. Let's get into this. And the way I look at this is I just take my time and go, okay, how many ALs do I have on the reactant side? I do want to look all over here. This is the only area where I have an aluminum, and I have one. I go now to the other side, okay, to the product side, and I look at this compound, and I only have one AL. So right now, aluminum AL is balanced. Okay, so I'm not going to do anything with that. I can come back and change it, and that's okay. I'm not saying it's done, but it's good for now. I now look at bromine. Bromine has 2 on the reactant side. On the product side, we have 3. This is going to be extremely common when we have 2 on one side and 3 on the other. I cannot just add 1 more. That does not work. Okay? And if I try to add 2, if I sit here and put a coefficient of 2, now I'm at 4, and that's not going to equal 3. Okay? So the way to catch on to this really fast is when you see you have 2 of one element on one side and 3 on the other side, we need to find the least common multiple, and that's not meant to be scary. The least common multiple is what's the multiple of these two numbers where they meet, and that would be 2 times 3 is 6. So I want to raise these up to 6. Okay? Bromines. So I go, what times 2 is 6, and that is 3. So now it looks like I have 3 times 2, 6 bromines. And then I do the same thing on the product side. What times 3 is 6, and that is 2. Look at where I place that coefficient. I didn't place it in between. I have people that want to stuff it in between the compound. That is incorrect. I put it in front. What that now means is it does mess up my aluminums. This 2 goes to this whole compound. I have 2 aluminum bromides. So now I have 2 aluminums, and so I have to come back and put a 2 in front of aluminum at the beginning. And right there, I now have a balanced equation. I should double check and go, I have 2 aluminums, 2 aluminums. I have 6 bromines, I have 6 bromines. And it is balanced. All right? The only other thing, this is going to probably be very rare, but it could happen, is if you can divide all the coefficients, if you can reduce all the coefficients together, like divide all of them by 2 or divide all of them by 3, and still have a whole number, you need to do that, but we don't need to do that in this case. Okay? All right, so that is my basic method, okay, is basically to sit here and go, I'm going to do it one more time. I have 1 aluminum, I have 1 aluminum, I have 2 bromines, I have 3. 2 and 3 raised to 6, so I'm going to put 3 times 2 is 6, and 2 times 3 is 6. But now I have 2 aluminums, and there we go, we're balanced. Okay? All right, next one. Na plus O2 produces Na2O. All right, I'm going to try to show you my other method that I like to use. It's not, I say I like. This is the only other one I kind of show to students if they just don't seem to kind of go back and forth very well. They can't count very well. All right? So what I can do here is I do write out basically what I have. I have 1 Na and I have 2 oxygens. Okay? 1 Na and 2 oxygens. All right? On the other side, I have 2 Nas and I have 1 oxygen. And I'm going to put a little like link between them. Okay? What this means is whatever I do to whatever I multiply into sodium, I have to multiply into oxygen. They are together. So I can't change one without changing the other. So over on the other side, though, Na and O are by themselves. The only thing is, and some people do this, sometimes they write O2 right there. Obviously, you can only keep on doubling the O's. You can't just get one more. Okay? So I have 1 Na, I have 2 Na. So I need to multiply this one by 2. Now I have 2 Nas. So for the moment, I look pretty good, which means, and what I'm multiplying by is going to be the coefficient. All right, so I'll put that up there for now. That looks good for the moment. But I have 2 O's on the reactant, 1 O on the product. So I need to multiply the O's on the product by 2. Well, if I multiply this O by 2, I need to multiply the Nas by 2. So now I have 2 O's, but I also have 4 Nas. Okay? So I'm going to put a 2 right there, but again, while my O's are now balanced, my Nas are now unbalanced. So what do I need to do? I erase that coefficient, and I go, okay, what times 1 is 4? I'm going to multiply this by 4. So I'm going to put the coefficient of 4 right there. And now I'm balanced. I have 4 Nas, I have 4 Nas, I have 2 O's, I have 2 O's. Okay? So that's the other method. So let's try some others here. This is again a synthesis reaction. What I do is I go, I have 1P, 4P, so 4. I have 2 O's and 10 O's, so I need to multiply 2 times 5, and I'm done. That one's pretty simple. Okay? I have H2 and I have H2, so hydrogens are good. I have 2 O's but 1 O, so I need to put 2 here in front of water. But now I have 2 times 2 is 4, so I need to put a 2 in front of H2, because 2 times 2 is 4. Do be careful of that. I do have people that are like, 2 times 2 is 4, oh, I need 4. No, now I have 8. I have 2 over here already, multiplied by 2. Okay, I'm going to skip that one. All right, let's try this decomposition. I mean, we'll do just a few more, but this is the idea. So, I have 1K, I have 1K, I have 1 Cl, I have 1 Cl. I have 3 O's and I have 2. Hey, raise it to 6. So, I'm going to multiply this by 2 and this by 3. That makes the O's happy, but now I have 2 K's. I need to get 2 over there, and look at that, 2K, 2 Cl's, 2 Cl's. I am balanced. Okay? This one is pretty much as easy as it gets. I have 2 Als, 2 Als. 3 S's, 3 S's. Done. Okay? I'm going to skip a little bit here. All right. Let's do this combustion one. So this is a combustion. I know it's a combustion. A couple reasons. Okay? The primary thing I see is that I'm creating CO2 and H2O, but then I go back to the front, hydrocarbon and oxygen. That's combustion. All right. So combustion. The combustion can be sometimes, some people think it's a little tricky, but there's a general trend that does develop. The key for combustion, I will say, is balance oxygen last. Oxygen. There we go. Okay? Balance oxygen last. That's like a kind of a big hint trick to do this. So 1C, this one's probably not going to be that tough, but 1C, 1C. 4 H's, 2 H's, so 2. That doesn't mess up my C, so I'm still good. I have 2 O's. I have 2 O's from carbon dioxide, and now I have 2 O's from water. So I have a total of 4 O's. Put a 2 right there. That one's not that difficult. All right. Okay. This one, we're going to see something that might happen here, I think. Maybe it won't happen yet. All right. C2H4 plus O2, another combustion. So now I start with 2 C's, so I need to put 2 C's on that side. 4 H's, so I need to put a 2 on that side. And what I get here now is this would be 4 O's. This would be 2 O's for a total of 6 O's. So what times 2 is 6? 3. I want to see if they got a tricky one here. That one's not that tricky. That one's not tricky. Okay, we got one here. So this is one that you can possibly run into. This was my other trick with combustion. All right, so I do the same thing. I have 2 C's. I need to put 2 there. I have 6 H's, so I need to put a 3 right here. 3 times 2 is 6. I have 3 O's, and I have 4 O's. I have 7 oxygens. Okay. This is what I wanted to kind of show you with combustion. This is something that can happen, okay, fairly frequently. I cannot get 7 oxygen on this side, on the reactant side. It has to be an even number of oxygens. So if you run into this situation, okay, where you have hydrogen and carbon balanced, but oxygen is not, and you have an odd number on the product side, what I recommend doing, and this works pretty much every time, is erase everything and put a 2 out in front of the hydrocarbon. Now rebalance, and most of the time, pretty much in this class, only probably if you get into a higher level honors class or something else like that, will this not work, because we wouldn't give you a problem like that. It'll balance. So I have 4 carbons now, so 4, I have 12 hydrogens, so I need to multiply this by 6. This is 8 oxygens, this is 6 oxygens, for a total of 14 oxygens. What times 2 is 14? 7. Okay. All right, last couple. I'm going to do 1 single replacement and 1 double replacement. There's one other type I do want us to find. Let's see if we can find it here. This. Okay. When we have polyatomics, treat this as a single element. Okay. Do not separate this out. Do not balance the P's and the O's separately. That makes it. The only reason that could possibly happen is if it somehow splits up on the other side. But if you see the same polyatomic on both sides of the equation, do not split it up. Balance it as a polyatomic. So what I mean by that would be, I have 3 Mg's, so I need to put a 3 right here. I have 2 PO4s. Over here, because it's not in parentheses, I only have 1, so this is going to be 2. I need to multiply that by 2. And then I have 2 H's, and I have 6 H's now, so I multiply this by 3. Done. So balance a polyatomic as a single unit. We'll do this one. I have 1 Ag, I have 1 Ag. I have 1 NO3, I have 2 NO3, so I need to come back and put a 2. Now, though, I have 2 Ag, so I need to put a 2 with the Ag, 1 Cu, 1 Cu. I am good to go. All right. I'll do this. This is probably my last one. So 1 Ca, 1 Ca, 2 Brs, 1 Br. So I need to put a 2 here. I have 2 NAs, 2 NAs, and then 1 CO3, 1 CO3. I'm balanced. So that's pretty much it, guys. This is a double replacement. As you can see, we just have to, you got to take your time. You have to stay focused. Focus on a single element at a time. That's usually the other mistake I see people do, is they try to somehow be balancing 3 elements at once. That just won't work. 1 element at a time. Treat polyatomics as a single unit if it appears on both sides. And that's basically it. Okay, you saw a couple tricks with combustion. You'll get used to those as you practice them and go from there. All right, thank you very much.